Hey everybody. So we are now going to talk a little bit about postsynaptic potentials. So before we do that, just a real quick background information. Neural integration, which means that the neuron's ability to integrate or to decipher information, refers to the information processing, decision making, and memory mechanisms of the neuron. Right? So the ability for the neurons to do those things. That ability is based on the postsynaptic potentials, also known as the PSPs, that are going to be produced by the neurotransmitters. So, depending on your body's ability to create these postsynaptic potentials, those PSPs will influence the processing ability, decision making abilities, and memory mechanisms of your neurons. So, the first one we're going to talk about here is an excitatory postsynaptic potential. So, an EPSP. So, an EPSP, or an excitatory postsynaptic potential, is the likelihood that the postsynaptic cell is going to reach an action potential. So in the previous video, we kind of mentioned this. Yellow is presynaptic, green is postsynaptic neuron. A signal is going to come down the presynaptic neuron. It's going to tell the vesicles to release a neurotransmitter. Neurotransmitter hits the receptors, and from here, if that reception, if that new stimulus from the receptors provides the enough sodium and potassium to enter the cell, enough to generate a new action potential, then there will be an excitatory effect, an EPSP. If it's not enough, there's no ESP to happen. That's it. That's all we're trying to say. Do we have enough of a signal to create another action potential? If so, EPSP. If not, not so much. We can have the opposite, which we'll talk about in a second, which is an inhibitory postsynaptic potential, meaning that the neurotransmitter's jobs is actually to prevent something to happen. But we'll get to that in a minute. If you have any questions on this slide, please let me know.